Looking at a question like number 4, which said, is the relationship linear or nonlinear, and how do you know? Okay, so our question here is it linear, or is this table nonlinear? Okay, so we know that if we have a table, we've got a graph, anything linear is going to be a straight line. Okay, so we know that's linear. An example of something that is not linear might look like that. It's got a curved line. Okay, it might have a pattern of some sort, but it's not a straight pattern of the change of y over change of x. So we know that if we have a graph, in order to make a graph into a table, that we need to find the rate of change. So we've got change of y over change of x, right? And so on a graph, you know that if I found this point to this point, and I found my change in my y divided by my change in my x, that each one of those points would be exactly the same, and I'd have stair steps that are identical, right? So when you're walking upstairs, when they're identical, that's a linear rate of change. If you walk up some really old stairs that have maybe sunk or they've cracked, your rate of change might be different on those stairs, and your stairs might look like this. Okay? And you have this little step and a bigger step and a bigger step. And if you look at that, that's not a straight line. And so that's not linear. So what we're looking for is to find the change of y over change of x in our table, and that would represent whether it's linear or not, would be if you can end up with the same unit rate every single time. The same unit rate on a graph would be straight. The same unit rate on a table would be simplifying out your table every time. All right, so change of y over change of x on our table looks like this, setting up our tool. Here's our math tool. And our change in our y here, our change in our y here is negative 8. I'm at negative 2, subtract 8, and I get negative 10. So negative 8 over the change in my x there is 2. 0 plus 2 is 2. All right, that's the first set. If I simplify that down to find my unit rate, it's negative 4 over 1. Okay, there's my unit rate. If this is going to be a linear table, that means my next set of change of y over change of x is going to be simplified down to negative 4 over 1. If it's not linear, it's going to be simplified down to anything else but negative 4 to 1. All right, I'm at negative 10. I'm decreasing by 12. Negative 10 minus 12 gives me 22. Decreasing by 12 for my change in my y. My change in my x is increasing by 3. Okay, so far I don't see that representation here, but if I simplify that down and I do negative 12 divided by 3, I do in fact get negative 4, and that's over 1. And so this unit rate for this set is identical to this unit rate for this set of changes. So therefore, I would have that constant stair rate. I would have, my line would be straight if I were to graph this. I'm going to say this is linear.